Hey, Rado, what happens when you point 40 Logstash instances to ingest 3.6 terabytes of data to Elastic Cloud Serverless?
I know what happens, but it's Friday afternoon and you want to do this in production?
Yeah, well, it's easier to ask for forgiveness than to ask for permission. So let's see how Elastic Cloud Serverless scales.
That's right. We are running a baseline test to see how Elastic Cloud Serverless handles large-scale ingest straight out of the box with no optimizations, no tuning, and no automation, just pure performance.
All right, break it down for me. What exactly did we set up?
We deployed 10 AWS C5 18X large machines, each running 4 Logstash instances, so 40 instances in total. We have a data stream configured on each machine, giving us 10 data streams overall.
So remind me, how much data are we ingesting?
We are processing a total of 3.6 terabytes of raw data across all machines. And to do this, each Logstash instance uses 20 workers and a batch size of 3,000.
All right, so can you show me the dashboard we'll be using to track this madness?
Sure. This is an example of an internal Elastic dashboard our SREs use to help them monitor serverless so you don't have to. From top left corner, we've got the average indexing rate along with any 400 or 500 errors. Below that, we're tracing the byte ingestion rate.
Okay, so that's the left, but what's everything in the center?
Here, we see the total runtime of our test, and just below it, the number of serverless pods in use. And at the bottom, we have a list of pod names and their allocated memory.
All right, are you ready to start this test?
I already hit the button.
Oh, well, okay. So I can see the dashboard moving, and it looks like data is being ingested in.
Yes, within first minutes, Elastic Cloud Serverless automatically starts scaling to meet our ingestion demands.
So we don't have to provision any additional nodes or tweak any configuration?
No, not at all. Scaling happens automatically and it's dynamic. And within the first 8 minutes, we had scaled up already 2 pods, each with 8 gigabytes of memory.
So if you kind of look here, I can see some 429s early on. Should I be worried?
You can, but you don't need to. In Elasticsearch, 429s happens when bulk requests are temporarily rejected due to resource constraints. Logstash is designed to handle those by retrying requests, ensuring continuous ingestion.
So as Elastic Cloud Serverless scales, these errors go away.
Exactly. And within first 11 minutes, the system scales and delivers enough resources, so our 429s stop completely.
So I'm noticing the pod count fluctuating. What's going on here?
Elastic Cloud Serverless first doubles the memory on a single pod before adding more horizontally. We started with 2 gigabyte pod, and then we quickly upgraded to 4 gigabytes, then added 3 more 4 gigabytes pods. And as ingestion pressure increases, the Elastic Cloud Serverless continues to increase memory and adds more pods. This happens until we reach 64 gigabytes per pod.
Oh, so we are also removing pods as more are being added with higher memory?
Smaller underutilized pods are removed dynamically, which explains why pod counts fluctuates over time.
Well, and the best part, there's no need to evacuate the host or manually adjust anything, right?
Yeah, you are correct. The system reacts dynamically and scales in real time for you.
All right, well, let's fast forward to 1 hour and 15 minutes into the test. So what's our final scale at?
So we just reached 20 pods and each pod with 64 gig memory. And we are ingesting a steady rate of 0.34 terabytes every 5 minutes. That makes roughly 4.08 terabytes per hour.
Wow, and there's still a lot more room to push harder?
Oh, absolutely. We could have used more clients, for example. We could adjust the event size or fine-tune Logstash settings or any client we use to push data in. But even at this baseline test, we are achieving already 62.5% of the system's maximum capacity.
Wow, that's amazing. So in 93 minutes, we ingested 3.88 billion documents. So that explains why the indexing rate drops off near the end in this chart.
Yeah, once ingestion completes, Elastic Cloud Serverless automatically scales down to minimize resource usage.
And in just 15 minutes, we've gone from 20 pods at 64 gigs each down to a single pod of 8 gigabytes without touching a thing.
Well, you had to touch the start button. And yeah, that's the beauty of it. It's effortless. It scales up and down.
So Rado, what happens when you point 40 Logstash instances to ingest 3.6 terabytes of data to Elastic Cloud Serverless?
Well, let me summarize. We started the test with one 2 gigabyte pod and ingested the data into Elastic Cloud Serverless. We scaled to 20 64 gig pods without any intervention or any automation on our side. Scaling was handled completely automatically.
Yeah, and the total test took about 93 minutes to ingest those 3.6 terabytes of data, which really comprised of 3.88 billion documents. And don't forget, we automatically scaled down to one 8 gig pod. Again, no intervention was needed on our side.
We proved that Elastic Cloud Serverless is easy to start, scales automatically, and still has plenty of headroom for bigger workloads.
So if we could do this on a Friday in production without alerting anyone, imagine what you can do. So give it a try to see how easy it is to scale with Elastic Cloud Serverless.
Thanks for watching.
Yep, thanks for watching.